Shut up, nerd! Does it work? I recently embarked on making some lenses out of a disposable camera and the lens of an old Holga camera, and in that video I mentioned that I was going to go and try and pick up some junk disposables from a local film lab. And did I ever? They gave me a literal garbage bag full of the things. So I popped it up here on YouTube wondering what I should do with them, and this guy sparked an idea up in the old brain. Yeah, of course, the viewfinder of these cameras is technically an array of lenses. Surely I can find a way to house those in some sort of 3D printed shell and pretty easily get an image. This is built after all. You know I'm going to give it a whack. Oh, and stick around because at the end of this video, I'm doing the very first built giveaway. Woo! But before we get into the building of it all, let's strip one of these bad boys down and look at the anatomy of a disposable film camera. There's actually a lot of great parts in here that I now have a collection of, so if you're seeing anything as I'm tearing this down and you think I should make use of it in an upcoming project, then hit me up in the comments. What should I do with all of this stuff? Now from the lab, and that's Hillvale in Brunswick in Melbourne in Australia, for those playing at home, great photo lab. If you're ever in town and need film developed, go there. From the lab they come defilmed, which makes sense because obviously they take the film out to develop, scan and print it. But basically if you're familiar with any other point and shoot film cameras, it's pretty much exactly the same thing, just slightly less accessible. Once you do undo the side clips and separate the front and back housing, you'll find an array of little cogwheels, springs, levers, and a circuit board and battery that controls the flash, and maybe an auto rewind function, I think. You've got the actual lens array mounted here on the front, and then you've got the viewfinder up the top. Now, the viewfinder is of course what you put your eye up to look through and compose your shot. And I say of course because I've looked at the viewer stats here on YouTube for the Built channel, and some of you are quite young and you might not have any idea what this contraption is. Yes, this is an iPhone 3GS. So this top-down shot of the viewfinder array serves as a pretty good blueprint of sorts for how I wanted to go about constructing this lens. I've basically got all of the dimensions I need right here, plus a little bit of guessing as to the average distance one would hold this to their eye, and bam, whack all that into Onshape, slap it onto the Sony E-mount model that I have from the previous disposable lens project, and it'll work right out of the gate, no questions asked. Spoiler alert, it did not, and that is not much of a spoiler if you've watched any of my other videos at this point. Through a slight oversight in dimensions, I ended up with a forbidden stroop waffle that I couldn't house the front element in, but a quick recalibration and I was printing again, and the first element went in with no problems. Now is probably actually a pretty good time to show you my thinking though, so you can see here it's a very similar approach to what I've taken with the other lenses. However, this time I basically just tried to carve out little gaps in the print, similar to how the array is held in the disposable camera itself, to hold these little lenses in place with the right distance between them once they're housed in the print. And the rear element is placed within the housing at a very specific point that I determined literally by eyeballing it, the rough distance to my eye while holding up the viewfinder to take a shot. So back to the print, and once again we've got another pause built in, which is actually super easy to do in Bambu Studio, if you don't know. All I've done here is create a support blocker that runs through this part, but just through the center of it, as we do need some little supports around where the lens mount is. But given that we know that these gaps that would otherwise need supports will actually be full of a lens after the pause, we just need to tell the printer to chill out and not to bother with any supports. Then you scroll through the layers and put a pause at the last layer before it starts to cover over the gap. Just right click and add a pause. We pop the last little lens element in, start the print back up, and bam, you've got little lenses embedded into your print. I actually had so much false confidence with this first attempt that I printed it in a pretty high quality with a bunch of ironing and other settings dialed in, so I'm actually really happy with how it ended up looking. It's a really nice print. And if you have watched some of my other videos, you might remember something called the Built Support Group, TM, which I'm happy to tell you came in clutch because I've dialed in the settings now through a bunch of input from commenters, so thank you. My general rule of thumb now is to double the layer height for the top Z distance. So if I'm going to print at 0.08mm, then I'm going to make the top Z distance for the supports 0.16mm. And then to make sure the surfacing is nice once you pull the supports out, especially in large overhangs, I set the top interface layers to 3 and the bottom interface layers to 1. Your mileage may vary depending on the print. Shut up, nerd! Does it work? Well, holding it up to the camera actually shows you that a little bit of light comes through. You get a bit of an image, and that's a positive first sign. But that's about the only positive thing that you can see from this attempt. As soon as we whack it on the camera, you can see that it's just completely blown out and it's a blurry mess. And that should have been obvious. Look at how big that rear element is. With no physical aperture blades inside the lens, there's nothing to control the light coming in and hitting the sensor. So why then does it work with our eye? Well, your eye has an inbuilt aperture, your iris. Literally another name for aperture is iris. So when we're putting it up to our eye and looking through to compose our image, our own internal aperture is controlling the light, hitting the light plane, which is our brain, I guess. Look, I'm not an optometrist. Okay, so back to the drawing board, and for this iteration, I've addressed the iris situation by adding a rear plane with a small pinhole in the back to control the light coming in, and this will also serve to help with focus, if we ever get to the point that we have an image. I also shifted the rear element back towards the image plane ever so slightly and added a bit of an extrusion at the front and chamfered it back towards the front of the lens element just to help control some of that light coming through. Having it sat proud would probably end up with a hectic, uncontrollable flare. All right, we'll dust the hands off, call it a day. Surely this is the ticket. And no, none of those changes made any difference, but it does look pretty cool. You get so used to seeing a spherical lens that it's a bit of fun to see a square front, or I guess in this case, a rectangle front lens. It kind of reminds me of this Lomo square front lens, but you know, not as legit. But there's no point in it looking cool if it does not work. I was a little stumped here because I couldn't quite work out what was the exact point of failure. Was it the front element? Was it the rear element? The distance between the two? The amount of light getting through? That's a lot of prototyping and broken down disposable cameras to churn through before I maybe had a breakthrough. So I did a little bit of caveman CAD. That's cardboard assisted design. Something I've seen a bunch of mechanical makers utilize, and boy was that a good shout. I basically cut a bunch of cardboard up, poked a hole in it, taped each lens element to the front and started just holding it up to the camera to see what I could pick up. It was crude, it was not without flaw, but it gave me the little bit of info I needed to keep carrying on. The big front element was the problem, which is a shame because that's what makes it look so cool, but we shall mourn and we shall move on. Having learnt a few lessons from the previous attempt at making lenses, I knew that my less than precision engineering and soft grasp of mathematics meant that I would not be able to really nail the distance that the lens had to sit from the sensor, so I opted for housing it in a barrel of sorts that would then sit within the round lens mount that I could slide in and out. Now, before you come at me and say that I should have made this a screw-on mount, I agree. However, because we're not dealing with a spherical element here, I can't have the rack focus be determined by twisting the lens. I have to have it go in and out. So I opted for a simple pressure fit sliding situation, and hey, this is an experimental lens. I can do what I want. And my friends, we're on. It works, it focuses, we have an image. The image is kind of weird and wacky, but it's not horrible. It's much more useful than the image I got with my previous attempt at making a lens, and this is from literal trash. That's a win. Molto bene. But this puny little rear element does not look half as good as the previous version, so to try and recapture some of that vibe, I just made the outer dimension of the tube much bigger. It was also a little hard to get the little tube to slide out, so I added a little finger holder on the inside as well. I also slightly shifted where the element sits in the extendo tubo, as I thought it might help with the infinity focus just a little bit. But then that or something else wacky in the print process happened. Potentially the little lens inside was sitting a little cockeyed in the mount. Well, that meant that this version had some weird optics going on. It was kind of out of focus. It wasn't really looking good. All good though, we're rapid prototyping again. Now, taking all of that learning into the next version, I started dancing with the idea of adding a mechanical solution to extending the lens barrel. The idea being to cut out this section below the lens, add a cogged wheel in, add some slots underneath the lens barrel for the cog to grab onto, and then have that whole thing twist via the cog wheel from the disposable camera that's used to advance the film once you've taken the photo. Brilliant idea, Tom. But for many, many reasons that didn't work out well, and it was making the whole thing look pretty fugly, not gonna lie. But I do really like the idea of trying to harvest more parts from these cameras, so I will keep tinkering with that idea in the future. It was just a little bit much to bite off for right now, so I moved on and took the simplest route home. However, this exercise was not without failure, as the lens itself produced a nice image, so whatever went wrong with that last print was hopefully sorted out now, and I do think it was just sitting weird in the print. It was about now that I felt myself becoming bored with the process of trial and error, so I decided to settle and move on to finishing this project. I knew which versions produced the best image, and I knew which versions looked the best, so I took a little time to refine it and reprint it in proper quality. Now for this final version, I've made a couple of small cosmetic changes to the little lens barrel. Namely, I've added a finger divot to move the lens in and out on the top and bottom of the inside of the barrel, and I've added some to the outer edges of the barrel as well. The front ones will serve to get the lens out when it's sitting flush, and the side ones means that I can focus it without getting my fingers in the way of the image. I've also extruded the front of the lens out by about 1mm so that I could chamfer the edge back towards the lens front, giving us more of that feeling that we got from back when we were prototyping using the bigger front element. I recently also got some matte charcoal filament that's been gently calling to me from under the desk. Tom, swap me out. So I swapped it out with my dwindling supply of matte black for this final print, refined my settings in Bambu Studio, and off I went to print. And my friends, I'm happy to say that this is a really fun lens that produces such a nice, pleasing image. Now it is quite cropped, but it does end up having a really close focus distance. It's pretty sharp in the center and soft and kind of weird on the edges. It's kind of giving this blurred vignette of sorts, which I can see working really well in some certain filming circumstances, certainly not all circumstances. And being able to manually focus it is proving to be very valuable, obviously. And paired with the Sony, the colors are coming up really nicely, even with this little bit of distortion, and there's also not that much chromatic aberration, which is nice. And I've talked about it a bunch in this video to this point, so if you haven't looked at the previous attempt at 3D printing a lens, you should check it out. I'll link it on the end card of this video. You'll get to see the learnings I took from that project into this one, and you can tell that on this channel, we're all about personal growth. Welcome. Whoa, it's Tom from the future here, and you know what? There's two things very different about the future. One, I'm shooting on the lens that I made in this video. Whoa, so meta. And two, I'm wearing a hat, so not much has changed. But during the process of editing this video, I've been taking this lens out to go and shoot some B-roll to show you fine folk what it looks like. And through happenstance, I accidentally put the lens insert into the mount backwards, and turns out that's actually probably how I should have designed it. I was having a little bit of trouble, admittedly, with the final version of this lens getting infinity focus. It was a really good macro lens, but I couldn't quite get infinity focus. And I accidentally put this lens in backwards, and all of a sudden, I've got infinity focus, as well as a macro lens. So you can see some of these shots down here by the river. If I've got a nice tight shot of the water here, you can see that we've got some nice beautiful blooming off the river where the sunlight's hitting it. And you can see in this shot here, if I go to the sides, we've got this weird vignette of blur, and then it's like dead sharp in the middle and, you know, blurry again off the edges, which is really nice. It kind of creates this kind of weird funneling, dreamy effect, but it's not too affected, so you can actually use it. And yeah, it's making those highlights bloom really well. And then if I tilt up from the rocks in the river all the way up to the trees, you can see that we're still pulling focus all the way through there, as well as being able to get that really close macro focus as well. And I'm talking really close macro focus. Like, we're probably like maybe an inch minimum focus distance for this lens, which is wild. So when we get into this next bit where past me is telling you about the giveaway that I'm about to do, go into that knowing that there is a caveat that I will slightly redesign this lens so that you don't have to put it in backwards if you are one of the people who end up with one of these lenses. Okay, let's rewind time, go back to past Tom, and land this plane. So that, my friends, is the built patented viewfinder lens, or the built Viewy for short. I'm going to print 4 of these out, a special run of 4 more of these lenses. So if you have a Sony E-mount camera and want to try one of these out, fill out the form linked in the video description. Do me a solid and follow the Built Instagram or TikTok page. I'm trying to get those up and going now that the YouTube channel is up and running, and I'll be more active in adding some behind the scenes looks at projects in process on those channels once we build a bit of steam there. Oh, and to also prove that you were here to the end and didn't just stumble on this giveaway by chance, the answer to the secret question is 488. Peace, love, and lenses, fam.